Okay, so I'm just going to explain what a composite function is. A composite function is basically when one function depends on another function. So, for example, if I have two different functions, f of x and g of x, a composite function, which is h of x, is basically a composition of f of x and g of x. In other words, it is formed when one function is substituted into another function. In this case, g of x is substituted into f of x to form a composite function, h of x. This right here, we write it as f is composed with g and is written as f circle with a little, it's an open circle that is not filled in. So f circle g of x, and is basically read as f of g of x. And that circle can be replaced by brackets. So we can also write it as f bracket g of x, or it can also be written as f circle g of x. Just to show you what that means in terms of the visual representation. So here we have a composite function, which is f of g of x, and in this case, this composite function is made up of f of x and g of x. So in other words, g of x is substituted into f of x. And if I just go back to how g of x is formed, g of x is basically dependent on x. So in other words, in order for me to form f of g of x, which is dependent on g of x, which itself is dependent on x, that means f of g of x is also dependent on x. So there's a relationship between f of g of x. In order for me to form this, I need to make sure that I have g of x that is formed. So the input here, which is x value, because of the function g, I get an output of g of x, which then becomes the input for f of x function. And then my output here is f of g of x. Just to show you what that really means in terms of a real-life application first. I'm just going to talk to you about an application of forest fire. So we're just going to consider a forest fire that spreads predominantly in a circular pattern, and we are going to consider its area, radius, and the time that the fire is burning for. So I want you to just direct your attention to the bottom of the sheet here, where you can see the composite function a of RT. This is a composite function which is dependent on RT. And looking at what RT is dependent on, radius is dependent on the length of time that the fire is burning. So just a little recap. A represents the area, R represents the radius, T represents the length of time. So here we can see the fact that the area burned for a forest fire depends on the radius of the fire, and the radius of the fire depends on the length of time that the fire has been burning for. As a result, the composite function a of RT depends on the length of time that the fire has been burning for. So in order for us to figure out a of RT, we basically need to know RT. In order for us to figure out RT, we need to know what T is. Therefore, A of RT can also be written as A of T because area is directly dependent on time as well.